Hello everyone. So this is Unit 4 quiz tutorial. Starting with the first question. So in these three diagrams, we make use of a lot of times conditional probability and also the Bayes formula. So this here the formula is already given, but I think this formula is a little complicated. So I tried to simplify it here because this is essentially conditional probability. So this is asking probability of M given that B is also occurring. So P M given B is actually probability of M and B together, so M intersect B, divided by probability of B. And probability of B in this particular case, since there's no direct probability of B given, we have to calculate it using the diagram, because B can happen either through M or through N. So that's why the problem thinks that it's helping you by showing the pattern. So finding M and B and then N and B and then adding, but it just makes it look complicated. So I'm going to follow this, which is going to give the same thing. So, and since I couldn't find the intersect sign, I just used and sign. So just keep in mind M and B, meaning M intersect B. So M and B happening together. So M and B is, according to the diagram, the probability of M is 0.5. And then from there, the probability of B is 0.3. So M and B is essentially 0.3 multiplied by 0.5, and I should put equals in front of it, so Excel automatically calculates. So that's 0.15, which is the probability of M and B happening together. And then the probability of B is, so again, B can happen in two ways. One through M, which is, we just calculated, it was 0.15, because it was 0.5 times 0.3. And then B can also happen through N, which is 0.5 times 0.4. So then we're going to add this 0.5 times 0.4, 0.4, and so that makes 0.35. So then the probability of M given B here, which is what they're asking, is these two divided. And if we just round to the nearest hundredth, that would give you 0.43. So that's question number 1. Question number 2 is very similar. So using the Bayes formula, so it's the same thing. So this time we're being asked probability of W given C has occurred. So what we need to do is find the probability of W and C together and then divide it by the probability of C. Okay, so let's first figure out the probability of W and C happening together and then find the probability of C. This keeps happening. So W and C, according to this diagram, so the probability of W is 0.7, and then from there C is 0.1, so this is C prime, be careful. So 0.7, 0.1, we just multiply those, 0.7 times 0.1, so that's 0.07, that goes on top here. And then the probability of C, so according to this diagram, C can happen 3 different ways. One through U, and then through V, and then through W. So that will be through U, it's 0.2, so 0.2 times 0.7, because see this is 0.7, and then plus 0.1 through V times 0.2. So that's the probability of C through V. And then plus, last step, 0.7, this is through W, 0.7 times 0.1. So that's 0.23. And so this conditional probability then would be the ratio of these two. And that would give us, if we just round to the nearest 3 decimal places, so that's going to be, let me see if there's an error here, because this doesn't seem like the right answer. Okay, so I noticed that the problem is asking probability of W given C prime, so which is the complement of C. So I totally got it wrong. So this is C prime. All of this will be C prime, so that changes everything. So we're gonna find C prime. And this would also be C prime. So that's gonna change the calculation. So probability of W given C prime, that's 0.7 times 0.9. So 0.7 times 0.9. And then C prime, again, can happen 3 different ways through U, V, and W. So this is going to be 0.2 times 0.3. Fix that. And then 0.1 times 0.8. Fix that. And 0.7 times 0.9. Fixed that. Okay, so that should be correct now. Okay, so I'm actually looking at number 3. Sorry, I'm a little confused. So this is number 3. So I just did number 3. So that's this is 0.818. Number 2 was right. It is asking PWC. So that ought to be, so again, looking at this diagram here. So then all those calculations, this is going to be 0.7, 0.6. And then this is going to be 0.1, 0.4. And then 0.2, 0.9. And then 0.7, 0.6. And that gives you 0.656. So this is the answer to number 2. And the one that we just did, we ended up with 0.818. That's number 3. But as you can see, the first 3 problems are identical. I mean, it's just the same type of problem using Bayes' formula through the diagrams and the conditional probability. Okay, so let's look at number 4. So in number 4, we're being asked to find the probability of U1 given that R is occurring. So there's a diagram here. So I've prepared the setup here. So this is, again, we're going to use the same formula. Probability of U1 given that R is also occurring. So this is conditional probability. First we have to find the probability of U1 intersect R. So U1 and R happening together. And then that divided by probability of R happening by itself. So I'm going to find the top part here and the bottom part here. So let me explain how I came up with these numbers. So U1 and R, so according to this diagram, U1 is here, this first column sort of, and R is this middle blue shaded region. So U1 and R, the intersection of U1 and R is just this piece where it says 10. So that's why this is 10. divided by the sample space, the whole sample space, so all of the numbers inside this rectangle added together, that's the sample space. So see 10, 20, 30, plus 20 is 50, another 20 is 70, plus 30, 100. So the sample space is 100, so that we just added all the numbers here. So the probability of U1 and R happening together is 10 divided by 100. So I'm just going to put equals here, so it automatically calculates, which is 0.1. And then same thing, what is the probability of R? So R is this oval shape in the middle, and it has 10 plus another 10 plus 20, which makes 40. So that's 40. And the sample space is again the whole rectangle, which makes 100. So 40 over 100, and that makes 0.4. And this conditional probability is then the ratio of these two. So this probability divided by that one, that gives us 0.25 as the answer to question number 4. Okay, so number 5 is a problem that we can solve just like these tree diagrams, because it is actually a tree diagram problem, but the diagram is not given, so we have to kind of construct it. So let me read this problem. So it says one of two urns is chosen at random, with one as likely to be chosen as the other. So we have two urns, urn 1 and urn 2, and because they are equally likely to be chosen, so this is like flipping a coin, the selection of each urn is just 50% chance. So they have 0.5 probability of choosing urn 1 and another 0.5 for urn 2. So then a ball is drawn from the chosen urn. Urn 1 contains 1 5 and 5 red balls. Urn 2 has 5 white and 1 red ball. So I put those down. Urn 1 has 1 white, 5 reds, and urn 2 has 5 whites, 1 red. So if a ball is drawn randomly, so if a white ball is drawn, what is the probability that it came from urn 2? So I realized I made a mistake in the setup. So it's asking the probability of choosing urn 2 given that the ball was white. Okay, so that changes a little bit. So the probability of choosing urn 2 given that ball was white, so that's probability of urn 2 and white, and then divided by probability of choosing a white ball. So this changes a little bit, and that's choosing white. Okay, so imagine if we had the tree diagram, we would have the urn 1 here, urn 2 here, and urn 1 would going out to a red ball and a white ball with probabilities attached. And then same thing with urn 2. So how can you choose a white ball in urn 2? So we just simply multiply those two probabilities. So the probability of choosing urn 2 is, remember, it's 0.5. So this equals 0.5 times. And what is the probability of choosing a white ball from urn 2? So urn 2 has 5 white balls and a total of 6 balls. So it's going to be 5 divided by 6. So that makes that. And then the probability of just choosing white ball in general. So white ball can be chosen two different ways, one through urn 1 and another way through urn 2. So that would be first selecting urn 1, which is 0.5, times white ball is 1 over 6. And then we go plus, now through urn 2, which is 0.5 again, selecting urn 2, times 5 over 6. So that's that. and then the probability of selecting earn 2 given that the ball is white would be the ratio of these two.